So I thought I would just take this afternoon session right after lunch and start with something that might keep people more awake. And so, Andy, I'm going to do my best on this. Can you play the video, please?
Ramping up delivery of renewable energy projects is a global challenge we have to meet. We're rising to the challenge one project at a time.
Hi, my name is Taylor. Welcome to Cutlass 2 Solar Project here in Texas. We're building a 218 megawatt solar facility comprised of nearly 500,000 panels across 1,100 acres. When complete, Cutlass 2 will generate enough clean power for 40,000 homes. This is my second utility-scale solar project. Cutlass 1 is already powering 20,000 homes in the area. My key motivation? How to build faster and smarter. We have a 10-month construction schedule and less than 3 months of startup and commissioning duration. Every minute matters. There's a lot of exciting digital innovation that we're using and piloting here to keep improving our results. Here's an example. This is SIBDOT, one of our GPS-equipped surveying robots that takes our design data for the piles, creates an optimized route, and marks the precise pile locations for our pile staging activities. SIBDOT has improved the survey time sixfold, from 20 to 125 piles surveyed per hour. We're also piloting a pile stager to help automate the entire piling process. That could help us pile 3 to 5 times faster than traditional methods.
Hi, my name is Wyatt. This is one of the drones that we use for quantity reporting, inspections, and quality validation. The large 2D footprint of solar projects is unique in that it allows us to use the drone from early design through construction all the way to client handover. Imagery from daily flights is uploaded and is shared with the entire project team for faster, safer, and ultimately smarter decision making.
Hello, my name is Jeremy. The most exciting part of all this is we've customized software for 100% digital delivery. This is first of a kind stuff where Bechtel, work processes and automation enable us to pull information from every element of the project into a full interactive map-based visualization. This makes real-time and data-driven decision-making easier and faster, and it's resulting in cheaper and more efficient delivery for our customers.
Hi, my name is Jorge. Our digital execution methodology allows us to provide the teams in the field with all the information they need on mobile devices. They use our mobile tools to upload data to the GIS production hub, compare design against as-builds, report or verify construction progress, complete quality inspections, resolve punch list items, and evaluate drone scans without the need to return to the office. Our custom automations automatically populate our turnover packages as work is completed. Even our customers are a part of our 100% digital delivery by signing system turnover acceptance on a custom digital platform.
Cutlass 1 was delivered 20% ahead of schedule. We had over 99% accuracy in the volume.
Piles were installed 50% faster. We saved 10% of the pile and paper cost.
We produced less paper records, saving around 10,000 sheets of paper. We're now more than halfway complete with Cutlass 2, and we're trying to beat that record.
Okay, so a number of those participants in the video are actually here in the room, and if you've got questions at the end of the session, ask them. Don't ask me. That's the brains behind the operation. I remember doing my first solar project for Bechtel probably 15 years ago. A long time ago. Yes, Libby, I am that old. And, you know, I remember it was a lot of people. It was a lot of paper. We had no robots, no mobile tools, and I think things have come quite a long way in that short 15 years. So good afternoon. My name is Kelley Brown. I do run our EPC operations for Bechtel's renewable business. I've worked in the industry for over 20 years. I am a proud mom of 3 children, and they are constant reminders of how technology is transforming our lives. I feel like renewables is the perfect intersection there because on the one hand, we can deliver a cleaner future for these younger generations, and renewables is a great place to introduce new technologies. Today I'll talk about why Bechtel sees our renewable future grounded in technology. I'll start with the challenges of the industry and go through some real-life examples of deployment-ready technologies, and then I'll talk about what we see for the future in technology. So let's start with the challenges. First off, we have to ask ourselves, how are we going to build better, faster, with less? Anyone that's familiar with the renewables business knows that every new analyst's forecasts increases on the solar, battery storage, and onshore wind deployments that are forecasted. The passage of the Inflation Reduction Act has only, I want to say exacerbated, but that makes it sound like a problem, but exacerbated the plans for the renewable future. We would expect in the next decade over 1,200 gigawatts to be installed in the US, and that's 3 times faster than any pre-IRA forecasts. So when you think about that, you can imagine every state has increases in their energy job postings and requisitions, and a lot of those positions remain unfilled. When we think about construction and what that means for our construction workforce, to support that, we have to bring on board 500,000 new construction personnel annually. And then I take that even further and we think about, okay, we've got 2.2 million building tradesmen currently part of the US building trades. Unemployment for construction continues to hover around 4%. And so what that tells us is that our construction workforce are 100% utilized. Like that is the issue. Our solar industry needs more talent. And in the next 5 years, it's expected that we're going to triple our needs. So how do we build more capacity than we've ever built, more efficiently, with fewer people? And we're at a construction technology summit, so of course we're going to adapt technologies to help augment our teams. Bechtel takes an approach called Minutes Matter, which is what we use to deliver our best-in-class engineering, construction, and project management, and that's more critical than ever. Our solar array, I think Taylor mentioned, our schedule there is about 10 months for that solar array construction. Generally, it'll be a 6 to 10 month period, so a very compressed period of time. And that period, we've got hundreds and thousands of job hours. That scales to millions of dollars, and so every minute matters. In fact, I think you'll hear some of our team members say every second counts. The foundation of Minutes Matter is that we optimize the impacts of scale. We do that to improve safety and health. We do that to increase production. We do that for continuous improvement. And Minutes Matter drives us to focus on digital solutions and things like you guys have already been talking about today, autonomous equipment and advances in that kind of technology. Integrating technology as the way we work allows us to effectively design, manage, and deliver for our customers around the world. So today, I'm going to talk about real-life examples, things that allow us to leverage digital tools, and I'm going to share how we believe that this small little case study in solar is a good blueprint for future larger construction projects. So firstly, I'll talk about incorporation of robotics into our execution as a way to reduce our labor constraints. We asked, all right, if we take the existing workforce, is there a way that we can make them more efficient, move them quicker so we can do more work? And of course, the answer is absolutely. When we get out to a project for a solar site, all you can see is fields and fields, either of trees or open, grazing meadow. And for us, we've got to stage the piles, which are the foundations that the solar arrays sit on. We have to stage those in a relatively perfectly straight line. And if you do that without the support of technology, your lines, I can tell you, are not very straight. If you've ever tried to navigate your way in the woods without a compass or something, you recognize the circles you can be going in. So a decade ago, when we think about how we put the layout together to allow us to stage piles, we did that with professional survey services. Usually it was several field engineers, and they were setting up to do survey, and at the time we did 2 points per pile. So we could make sure we had the right orientation. What would typically have taken 15 specialty crews then takes one crew with robotic site layouts. Bechtel was one of the first EPC adopters of the CivDot, which was featured in the video. And the CivDot we use our GPS-equipped robotic solution where our GIS design data is fed to that onboard computer, as you saw. And it's kind of simple. It spray paints on the ground where the piles are supposed to be located. And we can follow up, and we stick a flag there. So even if you're a good distance away or you experience rain, we still know where the piles go. So with this solution, a single craft crew can do the entire pile layout for the project. Again, I think we said it on the video prior to this solution, we're talking about, flagging 10 to 20 piles an hour. Now we can do 1,250 piles a day. The other benefit here is we're able to transition from the professional services of a field engineer or teams of field engineers to craft professionals. And with the success that we've experienced with pile layout, all of our materials have some sort of layout requirement. And so we're taking that on to some of our other work activities like solar panel staging. One of the best news in my mind as an ops manager responsible for our delivery is that the robotic solution requires only about 10% of what we would typically incorporate in our budgets for survey. All right. So now we'll go on to GPS machine-controlled equipment. And I feel like I'm repeating a lot of what many people have been talking about today. For us, we're a user of that GPS machine-controlled equipment. So just to put in perspective, and I've talked about it, I probably should have introduced it before, but solar piles are essentially steel I-beams. They weigh about 200 pounds each, and usually it's a very manual process. Those piles need to be driven in the ground, 8 to 9 feet of embedment usually, and within a 1-inch tolerance. And so when we talk about, how precise we need to be, the elimination of human error is really key. Traditionally, to install these piles, you assume that you've got the right pile close to the right location. We had templates on the ground identifying where we should be where we should be installing those piles. And we'd run a string line so we could make sure we get the right drive to height pile situation. And we'd also pre-mark every pile for the proper embedment. During that process, you'd start the pile driving, you'd stop, the field engineer would come, check for level, check for rotation, and then you're visually watching the pile drive down till you get to that string line and you stop. Our pile drivers are GPS equipped with machine positioning and auto stop sensors. So no more lasers, no more string lines, no more eyeing where we're going to get that pile installed to hit the right elevation. The same data that feeds the CivDot, our design data, feeds our pile drivers. And the screen, as you saw in the video, helps the operator navigate and identify the right location for that pile. All of the design information is there on board. I think the other benefit here is you don't have printed work packages or big drawings, and you don't have to worry about them being outdated. It's all right there on the pile driver. So as soon as the operator finds within that bullseye where the pile needs to go, the operator will start the pile driving process, and the machine will start recording construction as-built. So again, you don't have to worry about, the potential for errors in data and transposing things. Once the desired pile elevation is hit, the machine will auto stop and will complete the as-built. It really sets the perfect foundation within that 1-inch tolerance for the follow-on activities for the solar array install, which is certainly a sequence. And the technology is, I think Wyatt might have mentioned, it's brought about significant improvements in quality, with fewer than 1% of our piles requiring any kind of rework. Not only does that type of, elimination of rework help us with the schedule, but it also means fewer people. All right. This is where I get out of my depth a little bit and why I brought the team of folks. So if you have questions in terms of the automation, you can talk to them. But when we've got the robotics and the GPS, there's this data automation side of things, which allows us to really focus on real-time progress and quality metrics. We have a simplified project schedule essentially built into this system, and we've got a great coordination process through digital means where we can identify field barriers, and the team can quickly recover from those barriers and make adjustments. So if we think about the pile piece, I'm spending a lot of time on that. That's the first critical step of our sequence. But all of that as-built data gets sent right back to our production hub and can get clashed with our design. So we can essentially do 100% digital inspection and compare our pile as-builts to the design. The system will flag errors, and then our field engineers can use their mobile tools and know exactly where the piles are that need to go for further inspection. So following the piles, again, it's a sequential installation. We go to trackers, tracker install. Trackers are the mechanical system that allows the panels that get installed on top of the trackers to track with the sun, and then we go to DC cable and so on. And you really can't complete, or you shouldn't complete, those work activities out of sequence. All of the commodities are connected via a trigger-based automation. So for example, we've got all of the blocks which you see on the screen. Those are like about 14 acres, so they look really small on the screen, but we've got 14-acre areas essentially, and the trigger-based automations will tell you, okay, piles are 100% complete in this area, we can go and turn over to the next step in the sequence. If the activity is completed out of sequence, the system will also flag us for irregularity and also to go check that. So it's very helpful not having to be tethered to the desk. The data then from the field is automatically real-time uploaded, and we use that for our dashboarding. We get information on progress, and we get information on quality, which is great from a project management perspective. I think from a field perspective and the small team, this kind of automation and the tools that we're using, mobile tools, really help with interdisciplinary communication, so to speak. We experienced the benefits firsthand of those automations. A project that I was managing, we were seeing that our tracker installation was taking a lot longer than we expected. And because we had the data, as soon as we figured that this was taking longer than we were budgeting and we potentially had an issue, we were able to go look at the sub-processes that were creating this longer duration than we expected for installation. broke the process down into additional steps and added and broke out our crews such that we could actually recover the schedule. And I only share that because had we not had that data available to us so real time, we would have missed our opportunity not only to recover the schedule, we'd have probably identified where the issue was too late, but we also would have missed the opportunity to ultimately end up with 5% labor savings. So for us, the data automation is critical for our small teams' communication. We can make daily process adjustments, real time, and then management gets to visualize all of this data in our production hub. All right, most people that I speak with have incorporated drones as part of their construction technology suite. And we've known and used drones for quite some time, primarily related to inspections, visual inspections on things like cell towers or wind turbines. The team really pushed to find ways to incorporate drone technology throughout all aspects of the project, from planning and estimating all the way through to commissioning. So again, as I mentioned, you get to a project, it's nothing but a field out there. The only thing missing are the cows, and we've got to figure out what we're going to go do. And usually, you don't have the time to traverse the full 1,500 acres of site. But drones and drone imagery can help us visualize some of those areas. We can find, piles of debris that need to be moved. We can find areas where the topography is maybe more concerning. It doesn't seem to be matching, what we've gotten from Alta surveys. So we'll use drones to help with that. We use drones to develop site clearing and grubbing plans. Again, there are certain sites we get to, and because of the brush and the tree cover, we can't get out to the middle of the field, and drone imagery helps with that. We use drone technology to validate topography. So a lot of, it used to be, back in the olden days, we had to mass grade sites. And you mass graded the site, and you knew you had very good terrain, and you were going to have your trackers with the plane, in the right orientation, and they would work. Now, those nice sites, first off, we don't want to mass grade anymore for a whole number of reasons, sustainability, just, to name a few, it's more expensive. But a lot of those nice sites that don't have a lot of undulation, those are gone. And so we have to deal with, undulating terrain. And they've got to be, our install has to be precise so the trackers will work. And so we'll do a drone clash, so to speak, with the design topography. We can confirm pile and panel staging. We want to make sure materials are where we need them, when we need them. And we use drones to help confirm quantities. So oftentimes our field members will be documenting quantities in their mobile tools, and we can use drones to validate that those areas have in fact completed. We use infrared thermography to inspect our field pretty quickly, and I'm just going to pause there for a second. I'm kind of sometimes a nerd at this kind of thing, where I really want to get down into the details and understand what's the deal here. So forgive me, I'm going to talk a little bit about our testing, but back in the olden days, we used to do IV curve trace testing, essentially, to confirm whether or not our field was ready for commissioning. And you do that at the string level, and you need a skilled technician to go do the test, take the data, analyze the data, and present the results. And it's a pretty time-consuming process, and it's so time-consuming that you do it just to the DC string level. You don't go down to the module level unless there's a problem. And you don't find out about that problem until you've already gone through, done the testing, and done the test result analysis. So you can imagine that you could just find yourself in a do loop where, you've got something wrong with the DC string, you understand that, now you've got to go down to the module level. With this infrared thermal imaging that's drone powered, we can actually evaluate the health of the site all the way down to the solar cell level. So IV curve tracing used to take us 3.5 to 5 hours per megawatt, which would be like 3 to 4 months to do the field. And with the thermal imaging, we can do that in like 3 to 4 days. We can gather all the imagery, and the processing usually only takes 2 to 3 weeks. So we can find issues very early in the process and support our customers through commissioning. We use drone technology, again, like I said, for planning, for quantity reporting, quality evaluations, and it's really helping with making safer and smarter decisions. All right, now the culmination, like I don't even want to say it in the French word, but like this is like the big deal for Bechtel and what a lot of our projects are looking at. We use an integrated construction execution platform that streamlines all of our workflows, improves our communication, and gathers all of our critical data in a single place. So we use a digital GIS production hub as our single source of truth. I think someone was mentioning, what it takes to have all of these different systems communicate, the APIs and that kind of thing. But I'm proud because our team has done that. And we are 100% digital. We take the CAD design, we take our schedule, we take as-builts, we take feedback from the GPS machine control, we take the drone data. All of that is put into one main execution map interface, and that's accessible via our web maps and our field applications, and it's available to everyone on our team. This GIS, accompanied by our suite of tools, allows every member of the team to see where we're at any point in the project and evaluate what quality we've achieved. I just think about having the background imagery of your field, of your solar field, overlaid with your civil design or with your electrical design, and having that kind of information available to you to help plan your work, identify equipment needs. It's very powerful. We're able to optimize where we want to put dumpsters. Again, things that would usually have done in the past, very manual process, we're able to optimize that now through the technology and the use of our platform. In our Minutes Matter world, site layout is critical, and minimizing non-value added time is key. So we talked about this traditionally in the past. If you're on any kind of construction site, you know what it's like to have big D-size, sheets of paper, and the wind is blowing, and somebody stained it with coffee, and you have a potential opportunity for errors. With our platform, we don't have that. It's all available to us, handheld. All of our teams can access on their phones or on their iPads. And the great news is, any changes in the design, it's automatically there. You don't have to go swap out a piece of paper from your work package or your drawing pack. We know that our digital execution has allowed us to eliminate 15,000 sheets of paper just associated with cable alone. And so the team has done a great job. I'll just tell you a quick story. When we first mobilized and restarted solar, I said, look, I don't want paper. I'm not going to set up a recycling service or a shredding service. I'm going to do that. So any paper that we have, we're going to put in this box, and then I'm going to drive it every week to get it recycled or shredded. I don't know if people knew they thought I was cheap, and so they didn't want to force me to spend more money on shredding, or if they didn't want to see me lugging this box to go take to shredding. We really eliminated paper on the job site, which was such a proud moment for me. So look, with our production hub and our integrated mobile tools, we've achieved 99% quality, across the board, across all of our commodities, piles, solar modules, you name it. And the digital tools really replace that once very arduous task of physical inspections and documenting via paper and getting the paper back to document management and ensuring that we had it captured and filed. I would say not only do we complete those inspections digitally, but we're also incorporating safety information into that digital platform. So if we have, a particular area that's being locked out, it's going to be worked on for commissioning, we have sort of this digital keep out zone identified through the mobile interface. Our GIS production hubs are single source of truth, and it does allow us to deliver safer and faster. So I think the real value of innovative technology is only judged by practical experience. And somebody said, the big contractors, they're not going to go after anything that hasn't been proven, and that's right. We'll test things, and that's the neat thing about solar is we can test technologies, but we're not going to go all in on a technology until we know it works. And so when I think about our practical experience, I know 100% digital is real. It's achievable. I think we're adapting to the physical world through technology. We're building truly in half the time we did 15 years ago with less than half the people. And so in my mind, the team's been successful. We're building faster, and we're delivering better. All right, I promise, stick with me, it's almost over. One of the things that I wanted to share too is that the proof points from our team are sort of proliferating across Bechtel. We've got a number of other projects that have heard of our proof points, and they're starting to test those. We've got an airport that's currently piloting a GIS production hub for a portion of their work. Our LNG projects are currently piloting that piling exchange that we talked about. Of course, their piles are much, much larger than ours. And we have some of our chip manufacturing facilities that are implementing drone imagery earlier in the process to help with planning. So what's next? Are we satisfied? Do we feel like we've done it? Yay, 100% digital execution in solar, we're done. Again, I think solar provides a really great opportunity to test new technologies. You get so many data points so quickly. The teams leaned forward and tested new technologies. Sometimes they're ready for deployment and sometimes they're not. I think investment in robots in construction, I think I read something, it's scheduled or it's forecasted to double by 2030. I think we'll be a part of that investment. I think renewables in the industry will be a part of that investment. You've already seen, I don't need to say any more on equipment, but we're partnering with some of the big equipment manufacturers to really push the envelope on autonomy. And, you've seen everything from bulldozers to pile drivers. I do think for us, we're going to look at autonomous cable installation and potentially earthworks. We'll see how that goes. Outside of equipment and sort of that physical technology, there are certainly digital tools that we think can help improve our execution. We're really, Sam, this one's for you, interested in generative scheduling, where we use advanced analytics, right, to help us better allocate labor or allocate equipment, materials. That technology, I think, will help us improve material staging and distribution. And, on one of these projects, we're talking about millions of parts and pieces. Help us improve our equipment utilization. That's one of my pet peeves. I hate looking out at a field and seeing equipment not moving. Utilization will be a big deal. And then alleviating some of those labor constraints just by sequencing the work better and maybe bringing down that peak labor demand. So I'd like to leave you with this. If adopting technologies into the way we deliver projects have the potential to capture efficiency gains, improve schedules, reduce costs, make it a safer environment for our employees, or help us with the solutions for labor constraints, well, I say this, hot jalapeno, why would we stop discovering the technology that can transform our industry?